And this is Damien with Vanport Mechanical. We're going to do a basic tutorial on a furnace heating system checkup. So let's go ahead and begin. We've got a series of supplies and tools. Here is a replacement filter. In our basic tools we have a clean rag to wipe things down with when we're through, to wipe off all our fingerprints, a stainless steel brush to clean our metal parts, a screwdriver that straight standard Phillips. We have an amp meter, 5/16 nut driver, and a 1/4 inch nut driver, a multimeter that's capable of reading capacitance. We have one that's capable of reading microamp sensor current, a jumper lead should we need one, a tool to clean the pressure switch port, a thermometer for taking temperatures, and a tool to hold the furnace safety switch closed when we're taking our measurements. So if you want to go ahead and begin, Damien, first thing we're going to do is replace the furnace filter. And this one goes inside the cabinet right there. Something to note. There's an airflow arrow. The airflow arrow always points toward the furnace. If there is no airflow arrow, look for reinforcement, wire mesh reinforcement showing on one side versus on the other. The reinforced side always goes towards the furnace. Whether it's downflow or upflow, doesn't matter. That airflow arrow always points, if you follow the return duct here, down and into the base of the furnace, that arrow always points in that direction towards the furnace. So go ahead and put it in. And another thing, I can't remember it, Damien can't remember it, so we always write the dates on the filter when the filter is changed. And the homeowner can't be expected to remember it either all the time, so by writing the date on it, if they look at it, they can see, oh, it was changed then. And if they need to have it changed or change it themselves, they can do it at appropriate time frames. So go ahead and reinstall the filter, close the cabinet. Now we're going to go ahead and remove the top panel first. This is going to be access to your burner compartment and pressure switch and draft inducer. The bottom compartment in this upflow furnace is access to the blower assembly and the electronic control board, the ignition control board. So first thing we're going to do, right here, the little black switch in front of you, that is a safety shutoff switch. If for some reason your furnace does not have one, or it has been bypassed, the next thing you will do is go directly to the circuit breaker panel and turn off the power to the furnace. Hopefully it's labeled. Okay, so whenever you're ready, Damien, next step would be to remove the sensor rod, which is right there. Okay, so be careful to save your screws. And you can see there, that's what that rod looks like. They're not always bent. Some of them are straight. Depends on the model of furnace and the brand. Next step would be to remove the plate that holds the burners on. Okay, one, in this case it's 2 screws. Sometimes, depending on the size of the furnace, it might be more than 3. Now, as you remove that plate, you'll want to be very careful because you have got something in here called a hot surface igniter that is fragile. If you bump it the wrong way, it can break, and it is right there in front of the, in this case, it's the far right burner. You might be able to see it, just barely. You'll be able to see it better once we pull the burners out. Okay, go ahead, start from the left-hand side, lift it up in the tray, and slip them out. One. And keep track of how many burners you pull. 2, 3, In this case, it's 5. This is the one where you want to be very careful so that you don't hit that igniter element. They'll take some abuse, but not a whole lot. And there you can see that igniter element a little bit better, I think. Maybe, sorry. Yeah, there it is. There you can see that. Okay, next step, you'll want to visually inspect what you can of the heat exchanger cells with a bright light. Look inside to make sure that you don't have any visible cracks or weak spots, crystallization of the metal. Again, being careful not to hit your safety switch. Okay, everything looks good. Everything looks good, Damien? Mm-hmm. Okay, now, next step, you're going to take your ohm meter and go here to this plug. That's the power to your hot surface igniter element. Go ahead and unplug it. Turn your meter to ohms. Unplug your sensor, or unplug your rod, and you're going to measure the resistance of that element, that heater element. That's what it amounts to. There you go. That's fine. We can see it. Go ahead. So go ahead and measure that. One lead in each terminal, because we're measuring the resistance across it. And there's 74 ohms. That's acceptable. When they start approaching 400 ohms, if it gets to 400 ohms, the most chances are it will not work. At 200 ohms, I would question it. This is for a carbide igniter. A nitride igniter will read significantly different, usually on the order of 15 to 20 ohms. So, okay, now you've got that. You're going to want to clean your sensor rod and clean your burners. Clean your burner sensor rod there. You use a stainless steel brush. These you can get at the hardware stores, or I get mine at Gun Show when I buy them cheap. But I use the stainless steel brush to prevent any kind of other particles from ending up on my burner or my sensor rod. Okay, burner face. You want to clean any debris off the burner face, paying close attention to the runners on the sides, because that's where the flame travels from one burner to the next. And eventually, the flame has to make the connection all the way across in order to prove so that the furnace will stay lit. So go ahead and continue cleaning your burners, Damien. One. There's one there, 2. Now what you can do is, as you clean them, you can go ahead and put them back in place if you want to. And make sure that the round guide on the side of the burner facing you goes over the burner spud. Then there will be, in this case, there's 2 slots on the side of the burner that slip onto the holders, onto the burner holder. So that's 2, so go ahead there again. And that'll be 3. Again, sometimes they get a little tricky to get them in and out of there, but you may have to bend on it just slightly on the rail that those burners set on to get them in. But again, make sure that they're clean. The burners themselves are clean. That's also part of the path for sensor current. Okay, and the last one, this is the one next to the hot surface igniter, so again, you're going to want to be extra careful with this one to make sure that you don't bump the igniter and crack it. It's kind of hard to see down in there. There we go, drops right in. Okay, Now, next step, go ahead and put your guide back on. And being careful of that hot surface igniter. Yep. In this case, that's where the longer nut driver works a little easier to get a hold of it. And a magnetic tool. We love magnetic tools. And sometimes they don't always go in according to plan. Again, be careful not to cross-thread it. It is a sheet metal screw, so we'll have to. And there you go, it looks like it's got it straightened out. There's more than one way to skin the cat. There you go. Okay, go ahead and reinstall your sensor rod. Again, watching so that you make sure that the rod itself sits in front of the burner, the last burner, on the burner opposite from your hot surface igniter, because that's the safety feature. It has to prove flame all the way across in order for it to stay lit. So now, what we're going to do next, you'll need to check the capacitor on the blower. In this case, this one is a 15 microfarad, and it reads plus or minus 6% for tolerance. So this is why it's important to measure these. Even though it says 15 on it, next step we'll go ahead and measure it. And microfarads are on the meter. You'll want to disconnect the two wires from it. Okay, one lead on each terminal. Okay, this one reads 14.7 microfarads. It is good. It's within the 6% tolerance. The tolerance will usually be found right on the label for the capacitor itself, along with other information about it. If you're outside of that 6% plus or minus, you are going to want to replace it. And then go ahead and reconnect your two wires. Reinstall it in the bracket and make sure you've got the bracket secured. Again, also watching to watch your ends on when you put this up so that it doesn't short this out. This should actually go there. That way the wires are not shorted out against the edge, that lip of the cabinet. the blower housing. And they are shielded from contact with other parts of the furnace. Okay, now double check your connections, your control connections here at the furnace. You don't have to be real hard on these, because if you do too much, you'll twist it off of the printed circuit board, and then you end up buying a circuit board. Make sure all of the connections are tight to the board, including the high voltage ones. Just push on them gently. You'll know if they're loose, they'll move. All your pin connectors. Okay, because most failures can eventually be attributed to a loose wiring connection. Next thing we're going to do is do the same thing at our furnace thermostat. So grab your little screwdriver there, and we'll come over to the thermostat in this one. Okay, in this case, go ahead and remove the thermostat carefully in the wall, pull straight out, and make sure that the connections are tight. Again, you don't have to be so that you can't get them off, but you want to make sure that they don't come off inadvertently through vibration or whatever reason. Okay, so go ahead and reinstall the thermostat, taking care that none of the wires get pinched as you do that. Damien, stand by just a second. I'll slip that back off. See this here. Let's lay these down a little further so that they don't get pinched on the edge. There. That means the insulation on that wire is very thin. It does not take much to go through that insulation and cause a problem. Okay. Now, the next thing we're going to want to do is come up to here to the top part, the burner compartment, and right behind her you'll see that little port. That's the pressure switch port. That's what senses the draft. So what you'll want to do is pull the tube off of that and clean that with a rod, a piece of wire. Paper clip makes a pretty handy tool too. In this case, we're using a small Allen wrench. This is what we have. And make sure that there's no debris in that, because if that plugs up, your furnace again will shut down on the safety switches as it should. So after you've cleaned that, go ahead and pull the hose off the other side of the switch and straighten it out, inspect it, look through it, look down through it, through the side, and then look through the end. Make sure, because they'll swear up and down to you that bugs and spiders can't get in it, and that's not true. I've seen it and had it happen. So always check for that stuff. They're just the good Lord's little creatures looking for a dry, safe, warm home. Unfortunately, the furnace is not a safe home for them. Okay, now let's go ahead and plug in your a hot surface igniter. Again, it's a one-way plug, so it only goes on one way. Yep, there you go. And then you're going to take your jumper lead and your microamp tool. In this case, go ahead. Okay, it will read 0 at this time. Okay, in this case, because it is a polarity sensitive device, the red lead is going to be where power is supplied, right there, to the hot surface igniter element, or not the hot, excuse me, the flame sensor rod. If you have to tighten them up a little bit, fine. Sometimes you can get it to slip under the plastic and stay secure. On this model of furnace, you have to do it in this fashion. Newer ones have specific ports. Newest ones do. Okay. And there's that one secure. And go ahead and hook your other wire up. Okay, so that is hooked up. Now you want to take your amp meter, and you'll want to get the first thing you'll want to get is the hot surface igniter current. And there, so now your 2 meters are hooked up. So the next thing would be to take your safety switch holder and, yep, right there. Go ahead and, so that your safety switch can be energized. And thermostat, now because we've turned the thermostats down, let's go back and turn the thermostat up. In this case, okay. Okay, now this furnace has a device on it in the control board that when the power has been off, when you energize the furnace controls, when there's an actual call for heat still on the thermostat, it runs for approximately 90 seconds to make sure that the heat exchanger does not get overheated and break it. So we're now waiting for that to cycle down and then restart. Hurry up and wait. Well, what you can do while this is doing this in this period is go ahead and get your current draw of your blower motor. While we're waiting for this, it's already running. Should be the medium-high speed in this one. And there is our current draw right there. So that's one measurement that we will record. And then the other thing, of course, your temperature, supply air temperature up here, the thermometer that we've installed. The other thing you're going to want to do is inspect your flue. Make sure your flue pipe is not broken or has no holes or anything in it to make sure that it is indeed safe for our homeowner. That's why we're here, is to keep our homeowner safe as much as possible. Inspect our cabinet for drains, broken piping, anything like that. In this case, it has air conditioning on it, but the drain piping is all secure, and so on. Again, inspect our flue all the way down. In this case, the water heater is right next to it. So go ahead and take a look at the flue for that too. Make sure that no flue is loose or anything, because then that pumps exhaust into the building. So now we're waiting for our furnace safety delay. Also, while you're waiting for that with the cover off, in this case you can look down inside, make sure none of the insulation that's on the inside of the cabinet, the ductwork that you can readily see, make sure none of that has come loose. If it has, you can go ahead and re-secure it. Okay, first step that's going to happen is our inducer comes on. Second step, the pressure switch proves. And now we are at our hot surface igniter that is lighting up. And can see it there, it turns red. And the burner's light all the way across. And now with the far left burner on this is where the flame sensor rod is. Now we have 2.6 microamps of flame sensor current. This is the safety feature to this furnace. And this type of sensor system has been used for probably close to 50 years on commercial applications or longer, and they've since adapted it to residential because the old thermocouple stuff, if the flame went out, the thermocouple with a pilot, if the pilot went out, that gas valve could stay open 3 to 4 minutes pumping gas into the building. This one, and Damien, if you'll go ahead and unhook your sensor rod, responds on the order of 2 to 3 seconds to prevent unburnt gas being entered into the home or the place of business. It's a much better system. Again, here we go. We've tested our flats, our flame safety. There we go. Flame again. Okay, so now the next thing we're going to want to check is we've already done our blower. Go ahead and check our draft inducer current. And that one, they usually don't read very much. 8 to 9/10 of an amp is all, 1/10 of an amp. If you get your amp meter too close to the motor windings, it will read all sorts of goofy things. Because that motor is inducing more current. So the further away you get it, the more accurate the reading is. Okay. Alright, so now we're checking our temperature rise. This particular furnace, if I remember right, is between 30 and 70 degree temperature rise, 30 to 60. Our temperature in the room started out at 70. We are looking for no more than 130 degree discharge air. This is an indication of whether our furnace is fired correctly or not. If we find that it is climbs way above our expected sensor reading or temperature split, we start looking for things like a blower turning backwards, a plugged evaporator coil, or again, once where we look down here, insulation falling off and blocking the ductwork. Because these require airflow in order to make them work. And we are at 107 and still going up a little bit. This one should go up to about 112, which is going to put us right in the middle of our range at about 40 degree temperature rise. It's going to take a little while to get there, but otherwise this furnace appears to be in good working order. So, Damien, if you want to go ahead and shut the thermostats down right quick, one last thing we will do to this. Actually, two last things. And when the thermostats are satisfied, the next thing that happens, but we simulated this by turning them down. And we're waiting for the burner to shut off. Up or down to the turbo. Okay, it takes a few seconds. And there, our burner shut off. Our draft inducer shut off. You can see it slowing down. There's that. Now after a period of time, so many seconds, the blower will shut off. You want to let it run to the shutdown point. See, there's our inducer almost to a stop. Okay. Damper's closed. Some of these have what seems like a long time, but it's like anything. Just hurry up and wait. Pull it down. Let's give it a couple more minutes. So I know it should shut down. Okay, now before we put the covers back on, one last thing we're going to do is take our rag, our wiping cloth, and kind of wipe the dust, any dust out. Make it look like somebody's actually been here and worked on it. Never hurts to take a few seconds and wipe them down. Loose particles, stuff. It just looks better when you're all done. Especially on the top. If the homeowner walks in and sees at least the top.